Hi everyone, my name is Strickx, and as Keith mentioned, I'll be talking about two specific RFCs and why they're important for documentation and how that's related to the deployment of 1.1.1.1 by Cloudflare 2 years ago now, 3 years. So first of all, I'll reiterate documentation matters. I think everyone agrees that for a lot of the things that we do in our day-to-day jobs in network operations, network architecture, network design, everything that we do is always somewhat related to the documentation that we write or that others have written for us. Specifically in this case, for example, it was really important for us because a while back, this was a ticket that ended up in my queue. It was, we were seeing a very specific switch in our Newark data center, so New York for all intents and purposes, spitting errors, but it wasn't just the regular CRC errors that we see pretty much daily whenever, there's an optic fault or there's a bent fiber, things like that. It wasn't just that. What we were seeing, this is a Grafana dashboard of the issue we were having. What we were seeing is whenever we shut down the port that was having the issues, the errors didn't just go away. No, the errors moved to a different port, which is very strange because this is a top of rack switch. So the endpoint termination there are metals. So we were just seeing broken traffic hit different metals on the egress ports, which was very strange because we didn't have a full understanding why this was happening, why we were seeing egress CRC errors on our Nexus switches. So then one of my colleagues, what they thought happened, or what they're trying to figure out is that because of the cut-through nature of our frame forwarding, it didn't do the CRC checks on ingress, but instead did a CRC clobbering on egress to make sure that we detect framing issues if there were framing issues. For some reason, though, we weren't seeing CRC counters increasing on the ingress, so we're not 100% sure that is the correct assessment, but it seemed quite reasonable for us at the time that that's what was happening. But that still doesn't explain why we were seeing traffic hop between machines like that. It shouldn't be like that, and it should definitely not be to a specific switch. So instead of just taking the switch out of commission and RMAing it, which is what normally would have happened, we decided to set up some TCP dumps. We're trying to debug the issue. So because there's CRC errors, we needed to turn on a very specific feature on our interfaces to be able to actually capture the packets, because otherwise they would have been dumped before they hit the kernel. And this is the output we got, right? It's, as many of you have probably already seen, it's just a standard TCP dump. But specifically, what was really interesting to us, what we were seeing is it was a GRE packet, specifically ER span. And that is weird because we don't run ER span in our network. We don't run any spans in our network, really. So that was already quite strange. So why are we seeing this? We went into it a bit further, and what we saw was that it wasn't the actual outer layer of the packet that was problematic for the Nexus switch. It was actually the packet inside the GRE packet that was having an issue. What we realized was that the Nexus switches apparently have this really annoying tendency to read deeper into packets than they really should. So instead of just analyzing the outer IP packet, which was just a GRE packet, it actually checked into the tunnel and it checked the CRC hash of the inner packet. And that was the frame that was broken, unfortunately. Unfortunately, though, as with quite a lot of things from quite a lot of vendors, not all of this behavior is documented, right? It's the same thing with, for example, with compilers where you have undocumented behavior. It's the exact same thing with our networking hardware, where sometimes just switches do things that you don't expect them to do, and then things just kind of go awry. So let's have a better look at that TCP dump. You see, that TCP dump had the destination of 1.1.1.1. So that is in and of itself quite weird. Why would anyone be interested in sending GRE packets to a DNS resolver? What we rolled is that documentation matters. What you're seeing here is an outtake from the Cisco Nexus 5000 documentation guide specifically on ERSpan. If you zoom in on that, this is what you see. You see destination IP 1.1.1.1. That's kind of awkward. So 1.1.1 has been online now for well over 2 years. We're almost hitting 3 now. You know, that's a pretty big thing. You would expect that documentation to have been updated. Unfortunately, that's not the case. I was able to pull that PDF only a month ago, so it's unfortunately still online with the incorrect IP addresses. But it's easy to blame others and not look at ourselves. This is a tweet that was done at the beginning of October. What you see there is a really nice image by our excellently skilled design team, but what you see in the right there might be a bit on the awkward side of things, namely 1.3.2.3.4. It's not as problematic as 1.1.1.1, but I think we can all agree that 1.2.3.4 is potentially an IP prefix that's being advertised right now and could potentially be used for network traffic. So it's not really a good idea to use that in your documentation. So maybe it'd be good to start thinking about two very specific RFCs. RFC3849 and RFC5737 specifically relate to addressing prefixes that are reserved for documentation. As we're all very much aware, IPv4 is severely resource constrained when it comes to prefixes. So we've now actually reserved multiple IP prefixes now for documentation, both in IPv4 and IPv6, indicating that it's clearly a problem that we should be aware of because we've got RFCs for it and we're reserving IP space for it. So I'm going to say that again. The RFCs we should be talking about and we should be looking at, and the RFCs you should always have in the back of your head when you're writing documentation, is RFC3849 and RFC5737. It means that for IPv6, whenever you're documenting an IPv6 proposal, or when you're greenfielding things and you don't have your own prefixes yet, or anything similar, or you're writing official vendor documentation, the prefix that you should be using is 2001 DB8, and it's an entire /32, so you can do all the things to your heart's desire without really having any constraints as you possibly could have if you'd only get a 48, for example. For IPv4, we even designated 3 separate IPv4 prefixes. It's 192.192.02/24. That is reasonably close to the 192.168 prefix, which might confuse some people. So that's why we also have the 198.51.100 and 203.0.113 prefixes. That is 3 prefixes that you can use to 3/24s that are available to be used for documentation, that aren't carrying actual production traffic, that aren't going to impact a network engineer that has to spend a week trying to figure out why we're seeing ERSpan to 1.1.1.1 to then realize we're seeing ERSpan to 1.1.1.1 because someone misconfigured a switch. Use these prefixes. They're not routed. There's no production traffic on it. There's nothing bad going to happen to you if you accidentally configure those prefixes to you. So now you know, right? I'm sure everyone here has had a story where they're looking at very strange data and realizing, well, this is broken. Well, this is one of those broken things. I know this was a very short talk, and it's only really there to inform you about 2 very specific RFCs, RFC3849 and RFC5737. Please use them more frequently. This is a call to action for everyone, not just vendors. It will include Cloudflare. I've done a very nice internal rant when I saw that tweet. So nobody's alone in this, but please start using those RFCs. And that's it from my side. Thank you very much.
Thank you very much, Tom. We don't have any questions that I can see just now, so if I can encourage everyone to fill in the poll whilst you're thinking up a question. We have a question in from Tom Hill. Did I see correctly that your outer IP packet source was 1.1.1.1 as well as the destination? How did that make it through your BGP edge?
That is very well seen. We allow that in our BGP edge specifically because it's 1.1.1.1. One of the reasons why we are on loan for 1.1.1 is that we have a better view into the trash, for lack of a better word, for the trash traffic that is being sent to 1.1.1. That's one of the specific remits for why Cloudflare is allowed to advertise that prefix. So the filters are quite wide on that because it is of interest to get that trash traffic.
Thank you. Any follow-up on that, Tom? Okay. Well, thank you very much, Tom.